this is going to be used at a later stage. Okay, now in this kind of questions, when we have find the angle between the hour hand and the minute hand of a clock when the time is 2:45. So how do we do these questions? It's very simple. So this is your clock. Right now it's 2 o'clock. So when I'm moving this and I move it at 2:45. So what did I do? Initially this hand, the minute hand, was at 12. It has moved from 12 to 9. So it has moved how many degrees? It has moved, as you know, it has moved 9 sectors. So we discussed earlier. So 9 into 30, which is equal to 270 degree. So the minute hand has moved 270 degree. Now at the same time, just look at the hour hand. Now when I'm moving the minute hand, the hour hand is also moving. So how much has the hour hand moved? For the hour hand, it is 45 minutes, and we told you that the speed of the hour hand is half a degree per minute. So the degrees it has covered in 45 minutes is basically 45 by 2 or 22.5 degrees, right? So now what we are doing is this minute hand has traveled 270 degrees, right? This hour hand, as we calculated, has traveled around 22.5 degrees, and this was the initial angle between them. So this also needs to be subtracted. So the angle between the hour hand and the minute hand will be calculated as follows. We take the degrees traveled by the minute hand. This also could have been calculated like this: 45 minutes into the speed of the minute hand, which is 6 degrees per minute. 45 minutes, which is equal to 270 degrees, right? So 270 degrees minus 22.5 degrees minus 60 degree. So this will give you the angle between the hour hand and the minute hand. So we just solve this. This is 210 minus 22.5, which is equal to 187.5 degrees, and that is the answer. So just to reiterate why we are subtracting the initial angle 60 degrees, you just take a look at this clock again. So in this case, the minute hand is traveling this much, which is 270 degrees. But to calculate the angle which is being formed between the hands, we need to subtract obviously the amount that this hour hand has traveled, which is, which we just calculated as 22.5 degree, but also the initial angle. So this thing is also getting subtracted. That is how we'll get this angle. So just to show you the thing again, this is the initial stuff. This hand is traveling this whole distance, but we need to subtract. But this hand comes till here. So what all are we subtracting? The angle moved by the hour hand and also this initial angle. If you take a look at the clock, you'll understand what I'm trying to say. In this question, we're trying to find out the angle between the hands of the clock at 9:15. So again, take a look at the clock. Right now we have 9 o'clock. So the angle between the two hands of the clock is this, which is 270 degree. Now obviously you have to imagine the clock in your head so that you can solve the question. When your minute hand starts moving, this angle, which was initially 270, will start reducing. It will reduce up till this level. So we have to subtract something from 270. Now what do we subtract from 270? Obviously the amount that the minute hand is traveling. So which is, how much has the minute hand traveled? It is traveling 15 minutes into 6 degrees per minute, which is equal to 90 degree. This is the minute hand. What has the hour hand done in the meanwhile? Again 15 minutes into half a degree per minute, which is equal to 7.5 degrees. Now if you look at the clock again, when your minute hand is moving and reducing the degree, the angle that initially was 270, The R hand at the same time is increasing that angle because it is moving that side. So now what we are trying to do is, initially we had 270, out of which the minute hand is trying to reduce that angle by moving 90 degree, but the R hand is trying to increase because it is moving away from the initial 270 degrees. So this is the final equation, and when I solve this I get 187.5 degrees. So in this question we're trying to find the angle between the hands of the clock at 7:20. So just imagine the clock at 7. Now when we start moving the minute hand, you can see that the angle is getting reduced. So what is the angle initially between the hands of the clock? That is, so at 7, which is 7 o'clock into 30 degrees like we talked earlier, which is 210 degree. So initially the angle is 210 degree. When the minute hand is moving for 20 minutes, it is reducing the angle. So the minute hand, so minus the minute hand, how much is the minute hand moving? It is moving for 20 minutes into its speed, which is 6 degree per minute. This is the minute hand. What is happening to the R hand in the meanwhile? Just look at the R hand. Obviously, when the minute hand is trying to reduce the angle, the R hand is moving in the opposite direction and increasing the angle. And how much does it increase? So we add, again it is moving for 20 minutes and the speed is half a degree per minute. So when I solve this equation, I get 210 minus 120 plus 10 degrees, which is equal to 100 degrees, which is my answer.